Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about SpaceX Polaris mission. So let's dive right into it. Now, what exactly we are talking about here is basically partnership between two individuals, basically Elon Musk, quote unquote, and Gerald Isomek. Now, this individual is very qualified. He's again very deep pockets and very huge bank balance. Plus, he's a actually qualified Air Force, basically pilot, so to say. So he knows what he's doing, so that's why people can trust him with, like, space missions, so to say. And there's supposed to be 3 missions inside the Pathfinder protocols of Polaris, basically like how Apollo was there, then what, like, Apollo 7, 8, 9, 10, 11, 12 things. Same way Polaris will also have 3 missions. Now, aim of this puppy is basically you will start with Dragon and end with Starship, meaning Dragon will be the test 1, then there will be test 2, then at the end they're supposed to be using Starship as a human vehicle. That's the end game here. And there will be many small first of its kind, meaning first time a laser testing, first time a commercial spacesuit testing, first time this, first time that. There are a lot of small first, but once you combine all of them, that becomes a very important milestone for future, meaning there are many techs that we have to develop. When Apollo mission was done, it was done on a almost like a LOL level, meaning, to give you a context of that, the lunar vehicle that was supposed to actually go on it was so thin, basically the material used was so thin, so barely held together, that if an astronaut put a foot in the wrong place, it will just punch through. That's how fragile it was. Like, it was like good luck kind of scenario. This time we cannot do that. We need something far more robust, something far more reliable, something that we can scale up to much larger population and, like, much more missions. So we have to do a lot of first before we are, like, we are ready to go to the moon, because this time we want to go to the moon and stay there. That's the difference aspect here. We are not just lol, we actually want to go there and stay. So first thing first is that they're gonna go far out, meaning height wise they will be the second furthest, because first furthest will always be the moon missions, duh, and the second would be Gemini 11 at this point in time, because they reached around 1369 kilometers in altitude from sea level, basically a elliptical orbit like this. Now again, this is very exaggerated, but you get that point. Like, they went very high up. Now basically space shuttle and International Space Station, they are not very far up, they are very close, they are like less than 500. So you get that point. Like, from a practical point of view, they are like almost twice or 3 times further than ISS. Now Polaris Dawn supposed to cross 1500 kilometers, meaning they're almost going inside the early parts of the Van Allen radiation belts, meaning Van Allen radiation belts are generally have 2 subcategories, and they're supposed to go inside them. Now, why would you want to do that? Well, that's the first thing, human study of Van Allen radiation belt, meaning what exactly happens to human body and how much they can do. Now, many times people are like, how the heck Apollo went there? Again, Apollo just ran through it. It's like they did not collect enough data, and not to mention Apollo time, it was a war project. Many people have no idea. It's like, in times of war, almost everything is justified. But when you are talking about peaceful time civilian mission, nothing is justified, meaning it has to work 100% of the time. So we have to do studies like this, where we can, like, okay, if we go through Van Allen radiation, this is exactly will happen, and we have conducted tests with real humans, then we can, like, have absolute confidence in our predictions. This, like, if we're gonna send humans through this, what they're gonna have, like, they may have sleeping issues simply because when they're going through that, their eyes might blink. It happens with Apollo astronauts also, because once they are outside of magnetic field, the neutron basically high energy particles from the basically cosmic sphere started to bombard directly the retina, and because it's so high energy, it can penetrate skull and all that. So even when your eyes are closed, it's like tick 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 tick, the lights are glowing. So again, these sort of thing we only learned after doing it. So that's why we have to have a human here. We know all the data, we have satellites, we got that, like, we know all the technical data about it, but what exactly happens to a human, only a human can tell you. So we have to do something like this, and all the analysis right now is projecting like minor to inconvenience. Basically, it will be equivalent to, like, getting bit too many x-rays, or, like, flying a high altitude plane for very long flights. So it should be safe. It is safe to best of our understanding and estimates, but again, at the end of the day, you have to do it in order to prove it out. So that's why they are going much higher than ISS, and then they can be like, no, we have confidence that we can actually survive going through this for long durations. Then we come to the spacesuit aspect. Now, spacesuit aspect is very problematic for NASA, because right now there are not that many spacesuits in this world. And what you see that Elon Musk spacesuit that everybody is wearing in crew and demo missions, they are basically what we classify as IVS, meaning intravehicular suits, meaning if for some reason, let's say you are in your Dragon capsule and a particle debris destroys air seal and you leaks out, it goes vacuum, the suit will protect you. Now it does work, everything is awesome about that, but it's designed for as a last resort, meaning Hope you never have to use this. However, when you are talking about extravehicular suit, meaning when you are outside of the system, it has to work. It's not like, last line of defense is the first line of defense. The first thing they are doing, basically adding redundancy, meaning for safety reasons, it must have enough fail safe that even something minor happening, like, particles hitting something, or basically high solar flux, micrometeorites. This, be mindful, micrometeorites have started to impact basically people in space, meaning ISS astronauts have issues where they, like, they suffered punches in their suit simply because of meteorites. This is a real thing. It does happen. Like, again, thankfully they are very small and no critical incident happened, but it is something that you have to design for. It is something that you have to be, prepared against. So they have to do that. And because of the very tiny basically diameter of international docking adapter, utilizing the old way of like having giant backpack, which you see in basically ISS spacesuits, is just not feasible. It will simply not go through. Again, it can be done if you unpack it, but again, that's taking extra risks and all that jazz. And not to mention, SpaceX have not developed that backpack yet. When you see that astronaut suit, you are seeing two components: first that backpack, and then the suit itself. Now, suit itself is responsible for making sure everything is working. Backpack is responsible for feeding everything, meaning feeding the air, scrubbing the carbon dioxide, all those things, temperature regulation, things of that nature. But that can be done by umbilical system was basically used in Gemini projects and all that jazz. It's an old system. It does work. It's simplified. So that's how they're gonna test the suit aspect of it. Is my suit redundant enough? Is that my suit does work or not? Now, consequence of this umbilical design and without an airlock is that it will expose the interiors of Dragon to a raw hard vacuum. Now, in principle, that should not be an issue, because inherently, whenever you are putting that what we call IVS, you are assuming that, let's say something bad happens, something like micrometeorite punches a hole, there is a vacuum. You are assuming that systems will still work. You are assuming the ship itself, the LCDs, the buttons and all that, they're supposed to work. Because think of it this way: what's the worst case scenario? You are in IVS suit mechanics is working, something bad happened, puncture, vacuum, no problem. Okay, but here's now the astronaut is like, dude, we cannot touch the screen. Why? The screen is blanked out because it's LCD and liquid crystal expanded too much. Now it's not working. Like, think of it this way, like what that would be the worst case scenario. So all of this sort of system is inherently designed in a such a way that it should survive vacuum. It should survive vacuum. Same goes for space shuttle, same goes for Starship, Starliner. Like, inherently it should survive it, because otherwise there is no point. Meaning, if seal breaks, every other components fail, what's the point surviving inside it? At that point in time, hope that computer has programming enough that it should do a safe landing, but good luck with that. So that's why, like, this is gonna be like very hardy test for Dragon capsules, where it's like, no, I'm solid from the outside, also I'm solid from the inside, meaning I can handle direct exposure to vacuum. And there is another core importance here is like, right now they are working on air, meaning nitrogen oxygen mixture. Benefit, it works. It's super simple. You don't have to think too much about it. Consequence, this puppy is very high pressure, meaning you need around 15 psi. Now, if you have 15 psi in something suit like that without ball bearings and all that jazz, good luck. You can't move inside. It will like, you're stuck in a T-pose permanently, because it will be like very hard for you to collapse like this. And that's why, like, whenever you see NASA suits design, they have a lot of ball bearings. It has to be there, because they tried to do it without it and it was too painful. It's just too goddamn painful for astronauts to move. So the best way to do that is basically reducing pressure. The easiest way of reducing pressure without harming the individual is basically going to pure O2 rather than nitrogen plus oxygen. Just go pure oxygen, reduce the psi to such a level where it's like more or less the same. From your lungs point of view, it will be the same, basically oxygen concentration wise, but you can reduce the psi to 8 psi. And benefit of other aspect of that 8 psi is that it leaks lower. Leak rate is much lower. If you have 15 psi, leak rate is higher. If you have 8 psi, leak rate is much lower, like exponentially much lower. So it's desirable. Consequence, you have to do what we call pre-breathing, meaning if you see in the movie where, like, astronaut is directly going, lol, I'm changing the spacesuit. Yeah, they did. If you do that, like, nitrogen in your bloodstream will be like, yeah, I don't like this. So there is a full step procedure where you actually degas your body from nitrogen, quote unquote. So those things have to be done, practiced in real life on real human, for this puppy to be done safely. And this will help SpaceX to secure contracts with NASA, because NASA right now is getting stuck worse and worse, because everything behind right now in NASA is running lol, meaning what happened to SLS, lol, what is happening to Starliner, lol, what is happening to the Artemis suit program, lol. Everything is just lol at this point in time. It's like, it was started as like 1 year delay to 4 year delays. It's like, we will be lucky if this actually comes out to the market. Like that's how bad it is. Like this is unacceptable amount of risk on delay on top of delay on top of delay. Now NASA is looking very seriously into creating a second partnership where they can be like, hey, can somebody else please provide a spacesuit? Not to mention Artemis is lol, but ISS is working right now, and all their suits have reached their expiry point, meaning they're like running on borrowed time as of now, as of me speaking about it. Now think of it this way: NASA gives out a contract, but every time Dick and Harry will claim, yeah, we can deliver you in this budget and this timeline. Most of them will not. But how do you know? How do you remove the garbage from the best? You simply have like, is anybody have actual experience? If SpaceX can say, hey, we went from IVS to EVS this quickly. Of course, there will be a lot more modification have to be done, a lot more bearings have to be added, maybe PSI has to be changed, a lot of things have to be done. But if they have shown like they go from a sketch to a physical product in this amount of time, that gives NASA the confidence. Is like, if we contract them enough money, they can actually deliver us, rather than it's like, oh yeah, the bearing provider is like, trolling us, or like, the fabric provider that is like, building that Mylar fabric and all that jazz is, yeah, they are trolling us. That is not acceptable. Like NASA is getting trolled hard at this point in time. So this spacesuit is really important for SpaceX to get right. Not to mention it will help them also. It's like if they have their own spacesuit, they no longer have to worry about subcontractors who are messing that part up. And NASA needs this. Like it is very serious for them. So that's why I specified this is a Pathfinder mission. If it works, it's really helpful for all. Then we come to the smaller aspect of it, which is much more important, that is comms. Comms was a very clear disadvantage of comms right now, is that when Inspiration 4 was done, people were complaining. It's like, dude, why the heck the live stream was cutting out so often? And like, live stream was done in small chunks. Reality was they were limited by the ground infrastructure. Now, there are better infrastructure, for example, Deep Space Network, like this puppy. Now, this is a national asset, meaning you can't just, oh, hey, can I use your, Deep Space Network? No, because Curiosity rover, almost all deep space mission and everything in the orbit that is high priority generally has going through this, meaning it's reserved most of the time. All its bandwidth is generally consumed. So you need something that has this sort of capability, but it's far more cheaper, quote unquote. So Starlink provides that. Starlink is the beneficiary of commercial enterprise, meaning you just pay for it. You don't have to worry too much about it. And that's beneficial for every other company that wants to do that. Let's say in future Rocket Labs wants to have Starlink as a communication backbone, they can buy the services, no problem. And when SpaceX is doing that, they don't even have to worry about paperwork. They're like to intra branch operation. You don't have to worry too much about it. And it should provide much more stable and high bandwidth, because they are utilizing laser as a signal carrier. Now, even if they use radio also, that still should be much better, because again, there is no atmosphere and satellites have the ability to boost the signal. Again, that's why they have solar panels. So even utilizing basically LEO constellation, they should have much thicker pipelines. Basically, the data bandwidth should go from few megabytes per second to few gigabytes per second. So the basically footage wise, barely full HD to 4K 120 FPS should be doable, and it would be far more redundant, far more stable, and there would be enough data redundancy that even if something bad happens, it should have like enough throughput, like whole telemetry data can be sent reliably. So this is also something that we have to test, and not to mention even NASA is taking this seriously, because realistically radio was good enough for 1969. It's not good enough now. Like you genuinely cannot go to a Congress and be like, we're gonna do this mission, but it's like somebody is like, what is the footage output of it? Yeah, it will look like ugly TikTok. That's not acceptable. It has to be top quality. You are pouring billions of dollars, and Isaac is basically an individual that is footing the bill. He did specify very important thing. It's like footage matters, because you are talking about humans at the other end. We see things. We need crisp quality video in order to be inspired. Like if kids see like in 55-inch TVs or 60-inch TV, like big astronauts, that's inspiring. That's like, damn, I want to do this, rather than like seeing postage size photos. Does not matter. So it has to be done. It is something that we have to sort out for Moon and Mars mission, a quality laser interlinks. And this is the easiest way of testing that, because while NASA is working on that, NASA will take 10-20 years to to reach finalization. Then we come to the final aspect. It's like, because this is a long-term project, this is not something that's going to happen tomorrow or like even 2-3 years from now. This is going to stretch for a long time. So idea behind this is very simple. The first mission, once they successfully concludes, it will provide a lot of data. Then they will wait for orbital testing of basically Starship stack. Once that's concluded, data from these two data points will be collapsed into defining the criteria and goals for second and third mission, because right now they are aiming for 3 missions, but it could be stretched to 4 missions or 5 missions. That sort of things could happen, easily happen, because end game what they are planning for, that's a bit extreme. Is like trying to have human mission on test flight on Starship now. That's easy to do if it's in orbit, because if it's in orbit, you can easily detect, hey, airlock is working or not, systems are working or not, and it's not under stress. It can work. But you want to put people while you are launching it from here, while you are landing it directly propulsively. So you get that, like you want to put people while it's doing something like this. So that's a different kind of stress goal. And even with Artemis mission, the idea is like this will go directly into space, and then utilizing either Orion, utilizing either basically starships or things of basically other nature, basically like Dragon capsules, they're gonna dump astronauts into the system, and this will go to the moon, because it, in this scenario, it will no longer have to fight with the atmosphere while people is inside in it. So it will go through the stressful environment, and it's like, I am chill, I got this. So they want to bypass that part. So they, again, that's the end game, but doing that, like let's say in 3 missions, target point is around 2026. That's cutting it close, very cutting it close. So I do expect the third mission is most likely not gonna happen. It may stretch the time way, or it may be like, fourth mission or fifth mission. I do expect to see that sort of delay. But again, the aim is very huge here. It's like from launch to orbit to landing, human inside it. That's bold. So let's see what happens in the future. So this was my presentation on basically SpaceX upcoming mission, Polaris Dawn. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.